Hello guys, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the problems related to the directional derivative. Myself Dr. Harish Garg. You can simply follow my YouTube channel and there is a playlist. You can find the playlist in this column named as Gate Statistics and you can see the various PY questions related to the gate mathematics available in this lecture. There is one more playlist called as the IIT Jam Solutions, and before watching this PY question series related to the directional derivative, I recommended you must watch my previous lecture, continuity and differentiability. I continue this lecture in the I use the same shortcut tricks in this lecture as well. So first of all, what is the objective is we will cover all those questions related to the directional derivatives from the IIT JAM and the GATE mathematics examinations. So how you can find the directional derivative? So it's a very simple. You have the two different cases. Firstly, if you have the given function f is differentiable or f is not differentiable. How you can check the function is differentiable, that I already explained in my last lecture of the continuity and differentiability. You must watch this so that you can understand this lecture in a very simple manner. So if you prove that a function is differentiable, then you can find the directional derivative by using this simple formula where del f is called as gradient of the vector and u is called as the unit vector. So where if you have the three-dimensional plane, then you can write this as also del f upon del z into k cap, and this is my u3 k cap. However, if your function is not differentiable, then you can find the directional derivative at the point x naught y naught is here, x naught plus h u1, y naught plus h u2, where u1 and u2 are my directions along the x-axis and y-axis. So this is the direction along the x-axis, this is along the y-axis. If this limit exists and unique, then you can say the directional derivative exists. Now how you can find the partial derivative, which is defined like here, and if you point at the point x comma 0 at the point 0 comma 0, you can substitute here at 0 comma 0. How you can prove that the function is differentiable? So as I told already in my last lecture, so if you have a plus h at the point a comma b, where capital A and capital B are my partial derivatives with respect to x and with respect to y. If this limit exists and unique, the uniqueness is the most important thing, then you can say f is differentiable. There is one more method as I told you in earlier, or in particular if you have the point 0 comma 0, then you can say a function is differentiable if this limit exists and unique. If you prove that the functional is my differentiable, then the partial derivative always exists, but converse need not always true. If these functions are exist, you can't say that the function is differentiable. However, if you prove that the function is not continuous, then it means it is not differentiable. So that's one of the most important concept for you. If you prove that the function is my differentiable, then this implies the directional derivative exists always. Fine. If you prove that the function is differentiable, how you can prove that function is differentiable? By using this concept. If you prove that the function is differentiable, then the directional derivative always exists, while converse may or may not be true. Another way, if you have the function of this particular category, then you can say a over c plus b over d is my continuous only when this condition hold. If this condition does not hold, it means the function is not continuous. If the function is not continuous, this again implies function is not differentiable. Fine. Now if you have the particular kind of the function sine and cosine, then this function is continuous for all m which is a positive, and differentiable only when this m must be greater than of this n. For example, if I say x square sine 1 over x, is it a differentiable? Yes, because m is my 2, n is my 1, so 2 is greater than 1. Yes, it's a differentiable. Is this function is differentiable? Sine 1 over x cube? No. This function is not differentiable because 2 is not greater than 3. Although this is a continuous, because for continuity we need only as a m is a positive number. So now let's start with this PY quotient series. So let's say first question is you have to find the directional derivative. So firstly you have to check whether the function is differentiable or not. Firstly we can check about whether function is continuous or not. So you can see I can use this concept. So A is my 2. So what is the A over C plus B over 2, which is not greater than 1. So what does it mean? It means it is not continuous. If it is not continuous, it means it is not differentiable. Fine. So once you know it's not differentiable, then we can find the definition of this as here. So f of point is my 0. So 0 plus h of A and 0 plus h of B minus f of 0 comma 0 divided by h, where A and B are my directions. So in this particular example they are given to you. This is my A, this is my B. So I can substitute this value. This is the HA and HB. I can substitute here. This is h square A square. This is h into B divided by h raised to power 4 A4 plus h square into B square divided by h. So I can written like here. So this is my cancel out. H square is also cancel. So it's a square B divided by h square A raised to power 4 plus B square. Now take the limit as h approaches 0. So this value becomes my A square over B. Fine. Now I can substitute the value. What is the A square? 1 over 2. B square is 1 over root 2. So it will be root 2 divided by 2. So 1 by root 2 is the required answer of this problem. Always check whether the function is differentiable or not. Fine. So I can simply use this concept A, B, C, D. So you can see in this case A is my 2, B is my 1, C is my 4, D is my 2. Make sure all these numbers are my positive. Okay, look at this another one. You have to find the directional derivative of f. So now you can see whether the function is differentiable or not. Clearly say this is my polynomial. So every polynomial is my differentiable function. Fine. So once it's a differentiable function, can you find the gradient of this? So what is the meaning of that partial? Because it's a 2D. So fx plus fy j cap. What is the partial derivative of f with respect to x? It's a ky. It's a 3x square y minus y cube of I cap plus partial derivative with respect to y is a kx minus x cube minus 3x y square of j cap. Now you have to find at the point 1 comma 2. So what is my gradient? At the point 1 comma 2 it is my 2k minus it is my 3 to the 6, it is my 8. So it will be 2k minus 14 I cap plus I can substitute here it's a k cube 1 4 12 into 1. So it is k minus 13 into j cap. Then what is the unit direction is? This is my unit direction minus 1 over root 2 I cap minus 1 over root 2 j cap. So it is given that this is my direction derivative. It comes to be 15 by root 2. So I can take the dot product of this. So root 2 will be the LCM minus 2k plus root 14 minus k plus 13 divided by root 2 is 15 over root 2. So what is that? It's a minus 3k plus 27 is 15. So k will be is a 12 by 3. 4 is my right answer of this problem. Fine. So always you have the two cases. If the function is differentiable, then you can find the direction derivative by the dot product. If the function is not differentiable, then we can apply this definition. Okay, look at this one. If the direction derivative of f at the point 0 comma 0 exists, so is the function is differentiable? So first way is you can check it, but otherwise if you don't want to check, there is no worry about that. You can simply start with this definition. Fine. So what is the point is 0 comma 0. So it's a 0 plus HA, 0 plus HB minus f of 0 comma 0 divided by h, where A is my here coefficient of I, B is my this. Now what is that? If y is equal to 0, the function is my 0. So this value will be 0 and the numerator value will be 1 plus x over y. So x over y will be a over b whole square. Now this is my directional derivative. Now it is given that the directional derivative exists. Fine. So what does it means? That if it is a 0, then it will be 0 only when this value is my 0. Then only it's a 0 by 0 form. Then you apply the L'Hopital rule. Then it will be my here. Then it only exists. It means a plus 1 plus a over b must be 0. So can you substitute the value of a and b? This is cot of alpha is my 0. So cot of alpha will be my minus 1. And they are talking about value of the cot alpha. This is minus 1 is the right answer. Now look at this another one. Again you can see this is my polynomial. This is my differentiable function because it's a sine cosine. Exponential is always a differentiable function. It's a polynomial, so it is a differentiable function. So we can find it's a differentiable function. So what is our directional derivative is? Del f dot u. But they are talking about the maximum rate of the change. So what is our tips for you? How you can find the maximum rate of change? The maximum rate of change is always absolute value of this gradient. If you want to find the minimum rate of the change, then it will be negative of gradient. Fine. Now we can find the gradient. This is the x, y, z. So find the derivative with respect to x. So it is a cos x into I cap. With respect to y, so what is that with respect to y? Is a e raised to power 2 will be cancelled out. E raised to power y over 2 j cap plus 2z into k cap. Now at the point of this, so at the point of p, what is the gradient of this? Cos pi by is a root 2 plus e raised to power 0 1 plus 2k cap. So can you find the absolute value of this? This is square root of 1 over 2 plus 1 plus 4. So 5, 10, 11 over 2 is my right answer of this problem. You can use your calculator. You can find it up to 3 decimal places. You can get this answer. Okay, f is a function which of the following is true. If f is differentiable at 0, then all directional derivative exists. That's the correct statement. I already gave you earlier tips. F is differentiable. Remember, if f is differentiable, this implies the directional derivative exists always. Fine. While converse need not be always true. If all the directional derivative exists, then f is differentiable need not always. It's not always true. So this option is cancelled out. If the directional derivative exists, then f is a continuous. Converse is not true. Fine. Because if the directional derivative all exists, then we can't say f is differentiable. So we can't say f is continuous. If the partial derivative fx, fy exist and continuous, fine, then clearly say f is my differentiable. Yes, this is the correct statement. Fine. One more tips for you. If one of the fx or fy, if one of fx or fy does not exist, if one of the fx or fy does not exist, this implies f is not differentiable. Fine. You always remember that. That's directly come in my mind right now by seeing this statement. One more tips that come in my mind is directly here is, if f is differentiable, fine, then this implies fx and fy both exist always. Fine. If fx is differentiable, then fx and fy both exist always. If one of the fx or fy does not exist, then the function is not differentiable. So in this particular example, a and d are my right answers. Okay, look at this one. Again, this is the polynomial. So polynomial is my differentiable function. The absolute value of the directional derivative. So this is my here. Fine. The absolute value of this. Clear? So what is the gradient? We can firstly find the gradient. It's with respect to x cap. I cap is a 0. J is my 6y plus 3z of j cap plus of 3y k cap. So what is that? At the point of this. So at point P. So what is the value of this gradient? At the point P, x is 0. So it's a 0 I cap. 6y minus 12 plus 3. So it's a minus 9 I cap plus 3y minus 6 k cap. Then that's fine. Now we need a u. U is the direction. So direction is always be written like here. So u will be my 2i cap minus j cap minus 2k cap. But remember, u is my unit vector, but it is not a unit, so I have to divide it by its length. 4 plus 1 plus 9. So it is my 2i cap minus j cap minus 2k cap. Sorry, it's a 2 plus 1 plus 4. So it's a 9, it's a 3. Now this is my u, so I can take the dot product of this. What is that? I cap will be 0. It's a plus 9 plus 12 over 3. So 21 over 3 is my 7. So the absolute value of this 7 is also 7 is my right answer. Okay, look at this one. A function is direction. Is the function is continuous? Because remember, this rule is not applicable. Why? You can see y of d. So if we take it separately, then what is the value of the y is a 0, but a, b, c and d must be greater than 0. Fine. So it means we can't say that a function is continuous or differentiable. So if you never know about that, we can apply always second definition. Limit h approaches 0. The point is my 0 comma 0. So I can say HA, HB minus 0 comma 0. What is the value of the 0 comma 0? X 0 comma 0. So this value is my 0. I can substitute this as here. Limit h of a. So it is my h cube is common. A cube plus b cube divided by h square. A square minus b square divided by h. So this h cube will be cancelled out. Fine. So the limit will be here. Now this is my unit vector. So this is my a. This is my b. I can substitute here. A cube 64 over 125 plus b cube 27 over 125. A square 16 over 25. B minus b square of this. So I can add them. It's a 691 over 125 into 25 over 7. So it will be 5. It will be 7, 13. So answer is 13 over 5 is the right answer. So you can divide them. 5 to the 10. 2.6 is the right answer of the problem. Always, if you remember that, if the function is differentiable, but here you never know whether the function is differentiable or not, always apply this definition for the directional derivative. Okay, the directional derivative of the function. So clearly say y square is my polynomial, this is my exponential, and both are my differentiable function. So this is the differentiable. If the directional derivative of this at the point here is 0, means del f over this will be 0, then we can firstly find del this. So it's a 2d x and y. So what is the derivative of with respect to x? 2 e raised to power 2x y square of this plus 2y e raised to power 2x of j cap. So at the point of p, so what is the value of this directional derivative at the point p? So 2 comma 1. So when y is equal to minus 1, it's a plus 1. It will be my 2 e raised to power 4 I cap. This is my minus 2 e raised to power 4 j cap. And this is not, this is the unit vector it is given to you. So what is my u is alpha plus beta j cap. So if I take the dot product, it will be 2 alpha e raised to power 4, 2 beta e raised to power 4 is 0. So what does it mean? If I use them, alpha is equal to beta. Then this value will be my 2 times of this. Now what is the meaning of the unit vector? It means alpha square plus beta square is my 1, fine, and alpha and beta are same. So what is the value of the alpha? It will be my 1 by root 2. So if I substitute here 1 by root 2, that means root 2 is my right answer of this problem. Okay, the point at which the gradient of the function is a 0. Gradient of the function is my 0. Fine. Now again you can see it's a continuous function, differentiable as well because it's a polynomial. So what is the gradient? With respect to x cap, 3x square minus 3yz of I cap, plus with respect to y is a 3y square minus 3xz j cap, plus 3z square minus 3xy of k cap. Now look at the options. If I substitute here, x is my minus 1, 3, y and z are there. So 3 plus 3 is this, because it's a 0 means this component 0, this 0, this 0. So for this case, this value is a non-zero. When minus 1, minus 1, minus 1, the first value will be plus 3, second value will be minus 3, so 0. This value will be 3, minus 3 again 0, 3 minus 3 again 0. So that's the right answer. For this third case, first answer will be 3, it will be 3, 0, 3y square, 3, x into z plus 3 which is non-zero, so this option is cancelled. First case is a 3x square minus minus plus 3 which is a non-zero, so the only right answer is B is my correct answer. Let temperature at the point T, the unit vector in the direction decreases most rapidly. So what is the meaning of that? In which direction it decreases most rapidly? The answer will be minus gradient of f divided by its modulus. Fine. And if they are talking about the increases most rapidly, then the answer will be positive del f over gradient of f. Fine. So now again, how you can find it's a polynomial? So what is the del of f? So with respect to x cap, with respect to x, it's a y square minus 2x z square of I cap. If you take the derivative with respect to y, it's a 2xy of j, and with respect to z, it is my 2 minus 2x square of z. Fine. Now at the point is 1, 0, 1. So at this point, what is my gradient? Y is 0, so this is 0. X is my 1, z is my is a minus 2y cap. 2xy is a 0, and x square is a 1 and 1 minus 1 is a plus 4 k cap. So since they are talking about the decreasing, I can substitute here. It's a minus minus plus 4 k cap divided by its unit length. So 4 plus 16, 20. So 20 will be 2 root 5. So 2 I cap minus 4 k cap. So 2 will be cancelled out. I minus 2 k cap over root 5. This is a j component, this is a j component. It's a negative sign. This is the increasing vector, but we need a decreasing vector. So the right answer is B is my correct answer. Okay, look at this another one. Whether the function is continuous or differentiable, derivatives exist or not. Okay, firstly we can check whether it's a continuous or not. So how you can check that? My function is under root of x square plus y square and sine y square over x. Fine. So what I told you in my last lecture, whenever you have seen x square y square, change into the polar coordinate. So x is my r cos theta, y is my r sine theta. So this function will be my r sine y square, that's a r square over r is r, it is my sine square divided by cos theta. So clearly say this will goes to the 0 as r will goes to the 0, because this function is my bounded. This function is my bounded, so whenever r 0, so it means this limit of r approaches 0, function is 0 and it is independent of theta. So therefore function is continuous. So function is continuous, fine. This is not continuous, is the cancel out. Now how you can check whether it is differentiable or not? Fine. And then we will check about its directional derivative. So firstly we can check about the directional derivative at the point 0, 0. Again, we never know what is the function, whether the function is differentiable or not. We can apply this definition at the point 0, 0. 0 plus HA, 0 plus HB minus 0, 0 divided by H. So if I substitute this value, what is the HA and HB? So under root of H square will be common, H will be common. So it's a H square, A square plus B square into sine of Y square over X. So Y square over X is 1H will be cancelled out, B square over A. So what is that divided by H? 0, 0 will be 0 divided by H. This value will be cancelled out. So what is the limit as H approaches 0? You can see this value sine of 0 is 0, which is unique and existence. So it means the directional derivative, now you can see what is the meaning of that. Directional derivative is 0 for all A and B, irrespective of the A and B. It means the directional derivative exists for all direction. F is continuous, directional derivative does not exist in some direction, but since it is independent of A and B, so this option is also cancelled. Now you can check whether the function is differentiable or not. Fine. Now remember, I have proved that the directional derivative exists. Remember, it does not mean that f is differentiable, but converse is true. But how you can find the differentiability? We can check the partial derivatives. Fine. So because how you can find the differentiable at the point 0, 0? So you have to take the limit f of 0 plus a or 0 plus h, 0 plus k minus 0, 0 minus a times h minus b times k divided by h square plus k square, where a and b are my partials derivative. So what is the limit at the point 0, 0? So x approaches 0, f of x, 0, f of 0, 0 over x. So what is the answer? F of 0, 0 is 0, y is 0. So once y is 0, sin y is my 0. So it's a 0. What is the limit of this? Y approaches 0, 0, y, f of 0, 0 divided by y. So whenever x is my 0, you can see x is 0, this value is my 0. So it's a 0 minus 0 over y is my 0. So this value is 0, this value is 0. This value is also 0. So I can substitute this value here. It will be under root of h square plus k square, it will be cancelled out. So it is basically a sine of k square over h, limit of hk comma 0, 0. Fine. Now what does it mean? If you now clearly say this limit not exist. Why? Because whenever h and k are 0, 0, it is not exist. So once it is limit is not exist, it means the function is not differentiable. So function is not differentiable. C is the only right answer. Look at this another one. You have to find the directional derivative of the u, this in the direction. So clearly say this function is my differentiable. So I can find the directional derivative by this one. So at the point of this, so firstly I can find the gradient with respect to x cap, 2xi cap, with respect to y is 2j cap, with respect to this is my here. So at the point of p, what is the point of the p? Gradient is my 10i cap minus 2j cap plus 0 k cap. Is this the unit vector? Yes, 9 plus 16 is 15. So this is my u. So the gradient into u is my directional derivative. So I can take that dot product 30 over 5 plus 0. There is no j cap and k cap is also 0. So 6 is my right answer of this problem. F is a differentiable function. duf, dvf are the directional derivative. So it is given that it's a differentiable. So what is the meaning of the directional derivative is del f dot u. This is the directional derivative of f in the direction of u, and in the direction of v is here. Then very simple. What is the value of this? Del f over del x I cap, del f over del y j cap, and these values are my unknown and this is my target. Okay, so I can call as a and b. So my gradient is ai cap plus bj cap. Now what is given to you? What is given to you? Del uf is my root 5, del vf is my root 2. Now I can use this. This is my u for this case. So what is the meaning of that? Dot product of this with this unit vector is my root 5. So a over root 5 plus 2b over root 5 is root 5. So that means a plus 2b is my 5. Again, del f is my here. So by using this u as my here, because this is my v, so it will be my a by root 2 minus b over root 2 is my this. So a minus b is my 2. I have the two equations. Now how you can solve them? You can subtract them. So 3b is equal to b. b is my 1. So once b is equal to 1, a will be my 3. So the sum of them will be my 4 is the right answer. Because a and b I have considered del f by del x. So this value is my 3. This value is my 1. 3 plus 1, 4 is the right answer. Okay, whether can you check about the differentiability of this? You can see again I can never use this concept here. Why? Because this value is y raised to power 0. So but this rule is applicable only when y is my greater than, when a b c d all are my greater than 0. Okay, so my function is x cube x square plus y square. Now fx fy, firstly we can find its fx. So what is that? Limit point is my 0 comma 0. So x approaches 0, x comma 0 minus 0 comma 0 over x. So what is the right answer? X comma 0. So when you substitute x comma 0, y will be 0. It is my x cube over x square. That is my x. 0 comma 0 is my 0 divided by x. So the answer is 1. What is my fy? So limit y approaches 0, f of 0 comma y, f of 0 comma 0 over y. So 0 comma y is, clearly says a 0. So 0 minus 0 over y is 0. So both are exist. He said does not exist. F and x exist, correct, and are equal, but you can see both are not equal. Is the function is differentiable and the directional derivative exists along any straight line. So we can see firstly differentiable. How you can check about the differentiable at the point 0? So h comma k minus 0 minus ah minus bk divided by h square plus k square of root, limit of h and k. So clearly say this value is my 1, this value is my 0. So what is the h comma k is? H cube h square plus k square. This value is my 0, a, this is my a, this is my b. So minus h divided by under root of h square plus k square. So what is that? H cube will be cancelled out, minus h k square divided by h square plus k square of 3 by 2. Now you have to take the limit as h and k both are 0 comma 0. Now there are two methods. Either you can take as a path of y is equal to or h is equal to mk, or there is no need to take the path. What is the degree of numerator? Degree of numerator is 3. What is the degree of denominator? Again it's a 3. Fine. So always remember, whenever the degree of numerator is greater than of the degree of denominator, then this limit will goes to the 0, otherwise not exist, otherwise not exist. Now you can see about that the degree both are same, but we need a strictly greater than. It means the limit does not exist. So if the limit does not exist, it means the function is not differentiable. So in this means the function is not differentiable. So that means the answer is C is the right answer. Always remember these tips. Fine. And if you want to calculate it, directional derivative exists or not, but anyhow there is no need to calculate because only one option is left. But if you want, I can calculate for you. This is HA HB minus 0, 0 divided by H. So I can substitute this value here, H cube A cube over X. H square will be common. It's A square plus B square minus f of 0, 0 is 0. So limit H comma. So H cube will be cancelled out. So you can say this is always exist. So you can say this is always exist. So it means the directional derivative always exists along any straight line as well as along the any path. So that's why C is my correct answer. Okay, look at this another one. F is a function defined on this R2 to R, which is defined like here. F is differentiable and here. Okay, remember students, if you have a function of this, for example mod of x minus 1, then we all knows f is continuous at x is equal to 1, fine, and f is differentiable f is not differentiable at x is equal to 1, that we all knows. So if you apply this concept at here, then according to you function is not differentiable at x is equal to 1, y is equal to 2. Then according to you, not differentiable at 1, 2, and function is continuous. According to you, this is the right answer. But that's a wrong approach. Why? Because this rule is applicable only on this one dimension problem, that is only on the R, when you have only one variable. But here my domain is R2. Then this concept is no longer working on higher dimension. Fine. So then how you can think about that? We have to apply the definition. F is differentiable, f is continuous, and here. So firstly we can check about the differentiability. What is the definition of this? Limit h approaches 0 at the point differentiability h comma k of this. Fine. So what is that? 1, 2. So it means 1 plus h, 2 plus k, minus 1, 2, a of h, b of k. Okay, so firstly we need to find the a and b also. So what is my a? Partial derivative with respect to x. So limit x approaches 0 at the point of 1 and 2 minus 1, 2 divided by h, if I call as a h. Fine. So if I substitute here, this is my x and this is y. So if y is equal to 2, this value will be 0. So this is my 0, and 1, 2 is again 0. So 0 minus 0 is 0. So this value is my 0. B, del f over del y. So I can take again limit h approaches 0. So with respect to y, so first component is preserved, 2 plus h and 1 plus 2 divided by h. Again, when x is equal to 1, again you can see this value is 0. So this value already 0. So 0 minus 0 is 0. So this number is also cancelled. And you can see the partial derivative of f with respect to x at the point does not exist, but we have existence. So this option is cancelled. Fine. Now, moreover, you can see that if what will happen, as I gave you the earlier tips, remember that what I gave you tips is, if fx or fy does not exist, What does it means? It means f is not differentiable. Fine. But if this example, if this option is the correct option, then clearly say this option is the wrong option. Fine. And this is the correct option. But we will see, now we have seen that this is existence. So I can substitute this value in our options. So this is my 0, this is my 0, f of 1 comma 2 is my 0. So this is limit. What is the 1 plus h? It is my mod of h. 2 plus k, this is my mod k, divided by h square plus k square. Fine. Now, what can you say about that? Is this, again we can apply the same rule. What is the degree of the numerator and degree of the denominator? Degree of the numerator is my 2, degree of the denominator is my 1. Is it fine? Now, what is the rule? As I told you, whenever the degree of, where I have written, I think I missed that, I rubbed that. Okay, fine. Whenever the degree of the numerator is greater than of the degree of denominator, the answer will always goes to the 0, otherwise not convergent. So it means this limit is goes to the 0. So that means it's a finite. What does it mean? It means the function is differentiable at the point 1 comma 2. So function is not differentiable, cancel. If the function is differentiable, what does it mean? Function is continuous at the point 1 comma 2. So this option is correct option. Now look at the last option. They are talking about the whether the directional derivative exists at the point of naught. So what is the definition of this? Limit h approaches 0, f of at the point of this. So 1 plus h a, 2 plus h b minus f of 1 comma 2 divided by h, where a is my this number, b is my this number. I will substitute a and b later on. So I can substitute here, x is my 1 plus, so the numerator will be this of here, and 2 plus hb, it means it's a mod of hb. F of 1 comma 0 is a 0 divided by h. So limit h approaches 0. So because a is my positive number, so mod of a is my root a into b, h mod of h into of this number divided by, so clearly say the degree of numerator is greater than the degree of the denominator. So the answer will goes to the 0 irrespective of the a and b, but he said answer is 1. That means this option is cancel out. So only correct option is a is my right answer of this problem. Okay, look at that. The rate of the change. Rate of the change means directional derivative. Now clearly say this is my differentiable function because it's a polynomial, it's a sine and cosine function. Then at the point of this, find the derivative with respect to x firstly. So 1 plus cos z of I cap plus with respect to y is a 1 minus sin z of j cap with respect to z plus minus x sin z minus y cos z of k cap. So at the point of p naught, what is the gradient? Because I need to find, because function is differentiable, so I can use this derivative as directional derivative. So at the point p naught, this value, x is equal to 2, so this value is my here. So z is my 0, so cos 0 is 1, 1 plus 1 is 2i cap, sin 0 is 0 plus 1 j cap, x is my 2, sin z is a 0, y is my minus 1, cos 0 is 1, so it's a plus k cap. Now you have to find the u in the direction from this, so that means you have to find the p naught p1 vector. So p1 minus p naught minus 2i cap, 1 minus, that's the position vector of p1 minus position vector of p0. So I can say 0 minus 2, 1 minus minus plus, and 2 minus 0. So plus 2j cap, 2k cap. Now you can take that dot product, that is the right answer. So minus 4 plus of 2 plus of 2. So that means 0 is the right answer of this problem. Fine. So this is the way you can compute it as this rate of change. Any doubt up to here? I think that's a very simple approach. I have told you it's a P1 minus P0. This one is the right answer. Okay, look at this one. Now you can see whether the function is continuous or not. Although they are not asking you, but let me check you. So 2 over 2 and its value is 1 plus 1 over 2. Is it greater than 1? Yes. So what does it mean? The function is continuous. Fine. Now they are talking about whether the function is differentiable, whether the function is not. Okay, they are talking about the directional derivative. So firstly we can find the direction. H comma 0, point is 0 comma 0, each case 0 comma 0. So 0 plus HA, 0 plus HB, 0 comma 0 divided by H. So I can substitute the value of the A and B later on. What is the A? This is my A, B. This is my A, B. This is my A and B. So HA I can substitute here. So it's a twice H square A square into B divided by X square Y square. So H square common, A square plus B square. F of 0 comma 0 is 0 divided by H. So I can written here. So it's a H cube, cancel out. So it's a twice A square B over A square plus B square. Now look at the options B. If I look about the A option, A is my root 2, 1 by root 2. So the answer is 1 over 2 and 1 over divided by A square plus B square. So the answer is 1 by root 2. So yes, first option is correct option. Look at the B option. A is my 0, B is my 1. So if A is 0, B is 0, answer is 0. But he said 1. A is 1, B is 0. When B is equal to 0, this value will be 0. So this is the correct option. Now the function is not differentiable. Function is continuous. Okay, so we can't say if it is a not differentiable, then if it is not a continuous, then we can say it's a not differentiable. So how you can check about that? At the point 0 comma 0, again 0 minus 0 comma 0 minus AH minus BK divided by under of H square plus K square. So firstly we can find the A, del F by del X. Find limit X approaches 0, F of, once you are in the examination, there is no need to write all these things. You can do it, many of the calculation in your mind. What is X comma 0? 0. 0 comma 0? 0. So the answer is 0. What is the B? Del F over del Y at the point 0 comma 0. Limit Y comma 0, 0 comma Y, 0 comma 0 over Y. So once it's a 0 comma 0, again you can see it's my 0. So this value is a 0, this value is 0. This value is also 0. So I can take the limit H comma K. So H square K square, H square K divided by this value I can written as H square plus K square of 3 by 2. Fine. Now you can check about the degree of numerator. What is the degree of numerator is 3. What is the degree of their denominator is again 3. So clearly say the degree is not greater than of this. It is not. So what does it mean? The limit does not exist. So if the limit does not exist means the function is not differentiable, and this is the same option he suggested. So it means the answers are A and D are my correct answers. Okay, look at this another one. The temperature at any point is inversely proportional to square of the distance. What does it mean? I can open this, it's a R K of this. If the value of the temperature at the point of this is my root 3, so I can substitute here. So at the point 0 comma 0 comma 1, what is my R square is X square plus Y square plus z square. So r square is my 1, temperature is root 3, so k will be my root 3. So T will be my root 3 over r square. Then the rate of change means directional derivative. Now clearly say this is a polynomial, it's a differentiable function, so I can use this definition. Fine. U, firstly I can find the u is my QR, so r minus q, so it is my minus I cap, that is a 0 0 1, this is my r and this is my 1 1 2, so 0 minus 1, 0 minus 1 and 1 minus 2. 1 minus 2 is again, because it's not a unit vector, so I have to divide it by its length, so 1 plus 1 plus 1. Then we need to find the gradient of t. Fine. So if I consider this is my f, then we have to find the gradient of f. Gradient of f means partial derivative of this, similarly with respect to y and this with respect to z. So how you can find this f with respect to the x? So it will be minus over r cube into del r over del x. Fine. So we all know x r square is my here. So if I found 2r, del r by del x is my 2x. So what is the value of the del r upon del x? It is x over r. Fine. Similarly, what is the del f over del y? The same quantity over r cube, it's a y over r, and same quantity as del f over del z minus 2 r cube z over r. So what is that? I can multiply this by I cap plus I can multiply this j and k. At which point? So the rate of change at the point of this q. So can you find the value of this gradient of f at the point q? This is the r4. Can you find the value of the r4 for this case? What is the r square is? 1 plus 1 plus 4. So it's a 6. So this will be my 36. 2 root 2 minus 2 root 3 I can take as a common. X I cap. So X I cap, Y j cap, Z k cap. Fine. Now I can dot product of this value with this here. That is my directional derivative. So minus 2 root 3 over 36 is outside. This into this, and root 3 is also. So it is a minus 1, minus 1, minus 2 divided by root 3. So minus root 3 will be cancelled. It's a 1 over 18. It's a 2, 3, 4 into 4. So that's a 2 over 9 is my right answer of this problem. So this is the way you can solve all these PY questions in a very simple manner. We will see the next lecture on the partial derivatives and its more lectures. Till then, you can simply like, share and comment on my video. Best of luck students. Happy learning.